Okay, 10-3, the geometric sequences and series. Friday and Monday we talked about the arithmetic sequence and the series. Now we're moving on to geometric. This stuff will be covered on your quiz tomorrow. Reminder, in a geometric sequence, each term is determined by multiplying a non-zero constant, r, which we labeled the common ratio by the previous term. The equation we will use for the nth term of any geometric sequence is here. A sub n equals a sub 1 times the common ratio raised to the power of n minus 1, again the number of terms equaling n. The arithmetic one, if we remember that one, was this guy. So the difference between the two, geometric, arithmetic. Okay, the example here is to find a sub n for the geometric sequence. The given information is in front of us. A sub 1, the first term of the sequence, is 2,400. The common ratio is 1/4, and the number of terms in this particular sequence is 7. So the goal is to figure out a sub n, in other words, the 7th term. So here we are, the 7th term can be found by taking a sub 1 times the ratio to the n minus 1 power. We have all the information that we need. We can simply substitute it into the equation and then use our calculators to figure out the 7th term in this geometric sequence. Using your calculators, take 1/4 or 0.25 to the power of 6. When you get that value, times it by your 2400 and you should get 0.586 as your answer. Go ahead and give this one a shot. You can pause the video and then fast forward to the answer if you want, or listen to me. Go ahead and listen to me work through it. So here we go. Same drill. A sub n, again 7 terms, so we're after the 7th term in the sequence. If we know that the first term is 2/9, the ratio is 3 to the n minus 1. Well, we know what n is, so we can take this and plug in 6. Calculator, 3 to the 6th power, whatever that value is, times it by the ratio 2/9, and you should get 162 would be the 7th term in this particular sequence. In this example, we are asked to write an equation for the nth term. Just like we did in the arithmetic sequence section, we will do the same thing for the geometric sequence. So knowing that our equation is here, we need our common ratio. We also need the first term. The first term is given to me, it's 1/2. The common ratio I can find by figuring out how do I get from 0.5 to 2, 2 to 8, 8 to 32, and so on. Well, 8 to 32, I know for sure I'm multiplying 4. 2 to 8, same thing. So I hope that 1/2 times 4 is 2, and it is. 1/2 times 4, 4/2, which is 2, which is a sub 2. Awesome. So we have a sub 1, we have r, we can substitute it now into our equation. A sub 1, 1/2, common ratio of 4 to the n minus 1. Now we put ourselves in a situation we could find the nth term. We can find any term of that particular sequence using this equation. Part B, we are not given a sub 1. We are given, however, the common ratio, so we can use this information to find what a sub 1 is. So we're trying to isolate that. A sub n, which would be the 4th term given to us, is 5. A sub 1 is what we're after, the common ratio of 6. Now if this is the 4th term given to us, then 4 minus 1 would be 3. And we divide 5 divided by 6 to the third power, and we see that a sub 1 is equal to 0.2. So in my equation, 0.2 times the common ratio of 6 to the n minus 1. I can now find the nth term, any term in this particular sequence. Here are a few examples. You could try them on your own. I will work them out, and we'll move on to the next type of example that we will expect of you guys. So here we go. Write an equation for the nth term, just like the previous page. So we need a common ratio. How am I going from negative 0.25 to 2? How am I going from 2 to negative 16? I know I'm times it by negative 8. Times it by negative 8. Negative 8, we're multiplying. So r is equal to negative 8. A sub 1 is here. I could put it all together. My equation, negative 1/4. Let's clean this up a little bit. Negative 1/4. The ratio, n minus 1 power. And we're done. Part D, we're given the third sequence. And we know that the common ratio is 1/2. Well, if I go from a sub 3 equals 8, then I know to get to a sub 4, I would have to times 8 by 1/2. Well, 8 times 1/2 is equal to 4. So if I take this logic and perhaps work my way backwards, I can say that dividing by 1/2 would give me a sub 2. 8 divided by 1/2 would give me 16. And a sub 1 would give me 16 divided by 1/2, which is 32. So there are two different ways to look at that. If you're given a sub 3, a sub 4, even a sub 5, 6, whatever, and you know the common ratio, you could work your way back, or, just like the previous example, you can go ahead and plug them into the equation. Whatever works for you guys. Now that I know a sub 1 and I was given r, I can put together my nth term equation. For the nth term, it's 32 times the ratio of 1/2 to the n minus 1 power. Something called the geometric means are the terms between two non-consecutive terms of a geometric sequence. We did this with arithmetic sequences. We will do the same here. The example shown is find the three geometric means between 2 and 1,250. So I'm going to call this a sub 1. And if there are 3 items, 3 in between 2 and 1,250, then that means that this guy would be our a sub 5. Okay, so what we can do is use this information to find our common ratio. If we know our common ratio, then we can take that value of a sub 1 and multiply it by the ratio 3 times to get our 3 missing terms. Okay, so here we go. Let's use the equation that we know. A sub n is 1250, the fifth term. A sub 1 is 2. R is what we're after, and if 1250 was the fifth term, then n minus 1 would be 4. Using our calculators, if we divide by 2, and then take the fourth root of this value, that would give us a value r, which is 5. Which means 2 to the next term times 5 would be 10, times 5 more, times another 5, would be 25, no, that's not right, hang on one second, 250, I believe, yep, so 250, so here are, sorry, I was looking at my answer key and it wasn't lining up. I had a sub 4 equal 25, and that was definitely incorrect. So here we go. A sub 3 is 10, a sub 4 is Nope, not a sub 3. Oh goodness, making all kinds of mistakes. A sub 2, 3, a sub 4. There we go. Alright, however you write your answer, either method is fine. If you want to go this route, that's cool. This would also work for us as well. Okay, find the 4 geometric means between 1/2 and 512. Go ahead and work through that examples, and your answers should be as follows. Once you find the common ratio, we can go ahead and figure out what the remaining 4 terms are there. The common ratio should be 4 in this example. Similar to the arithmetic series, we have another equation for something that we use for the geometric sequence, not the arithmetic one. So this is the equation that we use. And some of the characteristics, we have the sum of n terms equaling a sub 1, which is the first term, which equals, times the first term of the sequence times 1 minus r to the n. R is the common ratio, n is the number of terms that we are finding the sum for, divided by 1 minus r. Again, these equations will be provided for you guys, so let's work through some of these examples. Alright, find the sum of each geometric series. We know A1, we know how many terms we are adding, and we know the common ratio. So it says find the sum, that means we are adding, we will use the equation S sub n equaling A1, 1 minus r to the n over 1 minus r. Well, A1 is 5, 1 minus 3 because r is 3, and n is 10, divided by 1 minus 3. Now, we will definitely have to use our calculators here. So, 1 minus 3 to the 10, divided by negative 2. That value, then multiplied by 5, please verify that 147,620 is our sum if we were to start at 5 and then times it by 3 and 3 more again, and we would continue to do that all the way 10 times, we would get a sum of 147,620. Okay, so here we go for part B now. We don't have the what? What don't we have in part B? We don't have the number of terms, n. So what we need to do is figure that out. We need to figure out what n is, knowing that a sub n is 125. So let's do that. Okay, we know r, and we know a1, and we a sub n. So if a sub n is equal to 125, we can go and plug this in to our geometric sequence equation. So 125, the first term is 2,000, r is 1/2 to the n minus 1. So let's see here. If I divide by 2,000, 125 divided by 2,000 is actually 1 over 16. And if I have 1 over 16 equaling 1/2 to the n minus 1, what could I do now? I could recreate common bases, couldn't I? Let's take you guys back to the logarithm chapter. 1 over 16 is the same as 1 over 2 to the 4th power, isn't it? So I have 1 over 2 to the n minus 1, 1 over 2 to the 4, so now my focus is on the exponents set equal to each other, giving me an n value of 5. You might have to rewind a little bit there. I'm kind of a little messy, but I can't scroll down for some reason, but that's fine. So yeah, go back and if you need to watch that over to see how I got n equals 5, do that, because it is imperative that we know what n is for our equation in the S sub n, the arithmetic series, geometric series equation. So let's do that. I now know I'm adding 5 terms, beginning with 2,000, and a common ratio of 1/2 to the power of n, which I found to be 5, over 1 minus 1/2. And we find that if we go to a calculator, 1 minus 0.5, 0.5 to the 5th power, 1 minus that value divided by 0.5 times 2,000, you get what I'm saying. Plug it into your calculator, guys, and verify that your answer is 3,875. So there can be tricky situations sometimes. Just like the arithmetic series, we can use the sigma notation for the geometric series. Okay? And so what we do for this one is we need a few things. We need to know what n is, how many terms are we dealing with for my equation. We need to know what r is, and we need to know what the first term is. If we know those 3 items, n, r, and a1, I can use my equation for the geometric series. It's not right. There we go. So let's figure out what n is, the number of terms. Remember, we start with the number on the bottom, we end at the number on the top. So we covered how many? 10 minus 3, which is 7, but remember to add 1, we are talking about 8. If you were to count it out, starting with 3, ending with 10, you were actually counting 8 terms. 3, 4, 5, 6, 7, 8, 9, 10. 8 terms. Terrific. What is r? Well, r, ironically enough, can be found right here. R in the geometric sequence is the number in parentheses right next to the first term, which is 2, and a sub 1 there, a sub 1 being what? Not 4. Careful now, it's not 4. We knew that the common ratio was 2, but a sub 1 is actually when I plug in 3 for k. So let me clean this up. It's actually when I plug in 3 for k. How about the eraser, rather? There we go. So when I plug in 3 for k, I have 4 times 2 to the 3 minus 1. Well, 2 squared is 4. 4 times 4 is 16. There we go. Now I have everything that I need to plug it into that equation. So s of 8 terms, we're going to add 8 terms of this geometric series, is the first term, times 1 minus the ratio to the 8th power over 1 minus 2. Calculator time, verify that your sum is 4,080. And that's your final answer. Moving on to this example, try this one on your own. Follow along with me. You pick. We need to figure out what n is. So we'll take 12 minus 4, but remember to add it back. So we have 8 plus 1, which is 9. A sub 1, let's do r. R is 3 in the geometric sequence. Now a sub 1 would be us plugging in 4 for k. So 1/4 times 3 to the 4 minus 1, because this is where we start, and this is where we finish. So our a sub 1 is not technically plugging in 1 for k, no. It's going here and figuring out, okay, we're plugging in 4 for k. So here let's do that. And we see that 3 to the 3rd power is 27, and 27 over 4 is just 27/4. We can keep it like that, or you can convert it over to a decimal. Doesn't matter to me. The sum of 9 terms is the 27/4 times 1 minus my ratio of 3 to the power of 9 over 1 minus 3, calculator time. Verify with me that I got 66,426 3/4. Sometimes we would want to know what a sub 1 is in the geometric series for which the sum is given to you of n equaling 7 terms, and r, your common ratio, is 3. So in that circumstance, we can kind of plug in values into our equation. For something else, we're after a sub 1 here. I know that S sub n is 13,116. A sub 1 is what I'm trying to find. 1 minus my ratio to the 7th power over negative 2. Isolating the a sub 1, verify, once you get around to doing the math, that you get 12 for a sub 1. And the last one here, last one, same drill as the one before. We will start off by our equation for the geometric series. This will be provided to you. Okay. The sum given to me equals A1, my goal. 1 minus my ratio given to me to the nth power, also given to me. So when you get around to it, verify that after you did all the math, first term in this sequence with a sum of negative 26,240, 8 terms in this sequence, the first one should be 16.